Sorry, apologies. Thank you, Andrew. I'm going to stop. Are you doing the slides? Sorry.
Yep.
Can I have the second slide, please? Andrew has introduced me, so I won't bore you anymore with more details of my experience. I thought I'd look at some of the technical risks involved in the construction of energy from waste plants, from the design through to the construction and through the operation. So from my experience, I've highlighted some risks that I've identified. So for design, you typically have floor design and fabrication and installation errors. We all know the construction risks that we have, but we also have commissioning risks and initial operation risks. There's also risks during operation of the plant, and I'm going to look at normal operation, risks during maintenance, and risks during non-routine operations. The plant design, sometimes you just get equipment that's not suitable for the process. You can have inappropriate equipment sizing. It could be designed for the wrong process conditions. Sometimes the wrong material selected, and sometimes simply you just get the wrong equipment from your suppliers. It could be as simple as a gasket that's wrong. So when that's installed, it could leak. Incorrect safety design, it's normally when the worst case scenario hasn't been taken into account for the hazards. And this tends not to be the process, but tends to be external factors, such as external fires. So if you've got a tank which has stores flammable liquids, it's not the process that gives you the worst case scenario, it's an external fire. For unsuitable equipment layouts, you tend to find that most equipment is drawn next to each other on drawings, but in reality, that's not the case when it's installed on plant. It's getting better with 3D models, but I've still seen sites where you've got plants or valves which are sort of 3 meters high in the air, and there's no way you can access those in a critical situation without any platforms or ladders. Fabrication errors, you tend to get manufacturing defects, poor quality equipment we're going to look at. And during installation, what you tend to find is that you have plants lots of sections of plant that are put together, but plants do move, they vibrate, and they get hot. And a classic example for energy from waste plants is exhaust systems. They're sort of installed when they're cold, but when the plant's running, they're hot, they get hot and they start to expand and leak. Next slide, please. I'm going to look at a couple of examples. The first example is a floor design, and it was a dispute I worked on. And this was an anaerobic digestion plant where the relief valve was fitted in the wrong location. It was correctly fitted on the outlet line of the gas system, but the line was routed to low level so you can maintain it easily at ground level. And what happened here simply was that over time, the digesters foamed, and you got slurry carryover, the line blocked, and also blocked the relief valve. The digestion process carried on, and it overpressurized, and there was a mini explosion, and the actual roof was blown off. Fortunately, nobody was hurt. This could have been easily sort of rectified if the relief valve had been fitted at the top of the line, or if an additional relief valve had been fitted. The second example is a fire at Tesla's Australia battery site. Here during construction, there was a leak on the cooling system, and that resulted in a thermal runaway reaction. And what you find with batteries, most of the incidents are normally due to incorrect design specifications. We know that lithium sort of absorbs water, it reacts violently, and sometimes there's been cases where you've stored lithium incorrectly, it's absorbed water from the air, caught fire, and the fire spread to other parts of the plant. I just wanted to highlight a couple of examples I've come across on other industries, which I think are relevant to energy from waste plants. I worked on a dispute for a furnace where the burners were fitted incorrectly. A supplier fitted his normal vertical design burners in a horizontal application, and they constantly failed. This took about 3 or 4 months to resolve. Fortunately for the clients or the contractor, they didn't have consequential losses. Otherwise, losses would have been a lot more than 700,000. The second was a tank design for non-flammable liquids and waste, but what wasn't taken into account was the waste degraded and generated hydrogen. The hydrogen then ignited and there was a mini explosion. Again, fortunately, nobody was injured. I'm going to look at construction risks. I've sort of broken it down to construction, commissioning, and initial operation. For construction, from my experience, sometimes you find that the workforce is just unskilled, equipment's not suitable for construction. And this is particularly true for newer technologies, because what you find is that you do have a skilled workforce, but sometimes you need a bit more skill. I've come across facilities that use exotic metals, something like Inconel metals, and where they've used stainless steel welders and all the welds have failed. Health and safety on sites tends to be paramount, but you do find corners are cut due to pressures on requirement to deliver the site, and often regular requirements are not met. Commissioning is slightly different. The commissioning team tends to be different from the construction team. And what you find here is that the health and safety risks are slightly different because you're working on a live system. And one thing that's not often taken into account is that when you're commissioning a plant, you tend to have construction on adjacent plants, and this can bring its own risks and hazards. Initial operation, I'm just going to look at, this is particularly true for new technologies. You tend to have a lot of unknown because it's a new technology, not dated, but you're starting the plant for the first time. And again, you might have skilled workers for other technologies, but they might not be skilled in the new technologies. So first example for my construction risks, I'm looking at an Indian power plant explosion where a boiler exploded. Sadly, 40 people died here. And the results was known as, was identified that it was due to hasty commissioning of the plant, and construction work was still being carried on the boiler system whilst it was in operation. The second example is a biomass plant in Teesside. And here it was a partly constructed plant, and there was a fire in the wood pellet silo. I mean, I'm not sure exactly what the reason was for the fire, but wood pellet silos are well known. You can get, if you don't use them for a while, what you find is that the biomass gets wet, it smolders, and it starts to ignite. During operation, there's a number of incidents. I've sort of categorized this into normal operation, maintenance, and non-routine operations. For normal operation, the highest risks are due to human error and equipment failure. For human error, it may be a simple case that the operator's unskilled or he's doing something he thinks is correct. Lots of human factor analysis has been done. There's examples where you shouldn't give any critical tasks to any operators late on in their shift because they might be tired. Equipment failure, that tends to be due to flawed equipment design. A lot of sites don't take into account any external factors like weather. I mean, biogas plants especially are prone to lightning strikes. You need to take into account, for some parts of the world, snowfall and earthquakes should also be taken into account. For maintenance during normal operation, during normal maintenance, it brings its own hazards and risks. What you find is sometimes the toxic residue still in the systems that need to be counted. One of the biggest issues I've identified is that often when people take things away, they don't reinstate them. And some of the biggest incidents of history are where equipment hasn't been reinstalled, but the plant's been restarted. Post-maintenance brings its own hazards. I mean, what you tend to find with post-maintenance, a lot of equipment's not designed for a restart. You tend to find, you tend to see higher flows, higher pressure rises, high temperature rises, and there's been incidents where equipment's failed. So it's really critical that the equipment should be designed for normal operation plus a fast restart. One of the most hazardous situations during normal operation is non-routine operations. And this is because the operators aren't normally used to doing this kind of work. During startup, you tend to have cold systems that need to be heated up. A steam turbine is a classic example. With a steam turbine, the steam has to be the right quality before it can enter the turbine. If it's not, there's potential for turbine damage. During shutdown, you have pressures in the system. Sometimes the equipment's hot, it needs to be cooled down. You've got to remember technologies like anaerobic digestion and gasification, they don't stop straight away. So you often need to give them some time to finish. One of the most hazardous situations on site during operations is non-routine maintenance. And this is because you're doing something on a live plant under a time pressure. And one of the biggest incidents on a chemical plant was when an operator was asked to cut a redundant pipe. He accidentally cut a pipe that was containing flammable chemicals, which was released and ignited. I just wanted to highlight this slide. This is a study that was carried out in 2011, and it showed that over 20 years, nearly 20 years of operation from 1970, nearly 75% of major accidents on continuous processes were due to non-routine operations. It worked out that you're likely to have an incident, 30 to 50 times more likely to have an incident during a non-routine operation. Although this study was in 2011, it's still valid today. I'm just going to look at a couple of examples. In 2020, there was an incident where 4 people were killed on a site during some non-routine maintenance on an anaerobic digestion plant. And this is because they were on the roof and someone was welding or doing some hot works on a connected conveyor. It could have been easily avoided if firstly, no one was allowed on the roof while the work was being done. Secondly, if the maintenance work was being carried out and the plant was isolated, the site could have easily just washed and cleaned the tank before they did work or checked for flammable atmospheres. The second incident is a biomass plant fire, which it was due to smoldering wood pellets, which ignited. I mean, it was a really large hopper that held 600 tons, and layout issue. If the silo had been laid out in a different situation, maybe it would have been a smaller fire. And I'd like to hand over to my colleague Trevor now.
Thank you. So, as Andrew said in his introduction, I work predominantly as a quantum expert, but I have also been involved in a number of advisory roles with waste to energy projects. Those have been projects which deal with processing domestic waste for gasification, and also biomass plants, which have dealt with both food waste and with other biomass materials such as wood chip, etc. I've also been involved with developers where we've looked at the system of grants, and there's a government system whereby you can refer to the contract for difference. So many investors in these waste for energy plants are looking for guaranteed income. And this was a system introduced by the government probably 10 years ago, whereby the price of electricity generated by these plants would be guaranteed by the government, so that the developers weren't at risk of fluctuations in the energy markets. Also, the drivers for domestic waste, energy from waste, has been the process of land tax. So previously, in the early 1990s, land taxes were introduced, landfill taxes were introduced. So people that are processing domestic waste had to pay a tax to basically bury the waste. And obviously burying waste has lots of other environmental impacts, which are very considered greatly today. So several of the plants I worked on that were quite complex MRFs, material recovery facilities. So take domestic waste and you want to take out the glass, the metals, cardboard, paper. So these are quite complex pieces of equipment. But then the balance of the waste was then used as the fuel, which is referred to as RDF, the refuse-derived fuel, which is the remaining products that can be burnt. And like I say, several of the plants I worked on were to do with gasification, where you're heating the organic matter to a temperature to produce a gas, and then that gas can be burnt at a very high temperature, and it's far more, the impact on the environment is far lower, and this is referred to as a syngas or synthese gas. So what I'm going to talk about now is some of the issues that occurred on some of my projects, mainly commercial matters. So the first matter I'd like to talk about is the structure or the industrial shed design of some of these plants. Many developers consider they can buy a biomass plant to process food waste or other biomass material, and they can just enclose it in a simple industrial shed. And this is when they're going through the procurement process with their contractors. This is what they try to develop to keep, obviously, the costs. If you're the developer, obviously you want to keep the costs to the minimum to maximize your outgoing. But unfortunately, I've been involved with events where a standard industrial shed has been designed to protect the units of equipment. But what has to be carefully considered is that these structures, or a sheds type design, is, shall we say, the minimum requirements to support the structure. And these biomass or other types of plants is more complex in terms of the requirements to support other pipe work, electrical equipment, etc. And also the ventilation system can be very substantial in these plants, which we'll talk about shortly. Also, you need to consider fire protection of the structure. And also, I worked on a project where we had major issues to do with the future maintenance of the plant. So some of these large pieces of equipment for biomass, etc., can be installed during the construction, but then there has to be facility for these items to be removed in the long-term maintenance and upgrading of equipment. And therefore, normally you will need access through the roof of the building for crane access to take out or to maneuver large pieces of equipment. So this is an issue which occurred on one of my projects. The second matter that comes up on several occasions is to do with ground conditions. So the typical scenario on some of these domestic waste plants is that they are located on an existing site. And unfortunately, most of these sites, which were previously council owned, a lot of them have been leased out to operators and developers, were previously quarries or gravel pits, etc., because they were ideal locations for burying waste, as I mentioned earlier, was the initial solution for, and unfortunately it still is the solution in many countries, particularly the United States, where they just bury the waste. They have the land to do it. Here in the UK, obviously, we have limited ability to do that. And obviously the environmental impact of burying waste and causing methane gas, etc., is a huge risk to the environment, or a huge impact to the environment. So the contractor has to be very careful when he considers bidding for these works in terms of the foundation design. So normally you'll have to use precast concrete piling system through the landfill mass to provide a suitable foundation for the building and support the large pieces of equipment. Also, there may be considerations as you're piling or digging into landfill sites, this can release methane gas, and this can be both hazardous and a huge impact on the environment. If you are working on a site such as previously gravel pits, which are very common around the London area, they can have very high water level tables. And obviously, as you're digging through this material, you're going to come through contaminated material, and then you have to be very careful, as if you're working for the contractor or as a contractor, to ensure that that is clearly covered in your contract, because every time you start disturbing the ground, if it's contaminated, then you're at risk of having to process that contaminated material. And processing contaminated material becomes very expensive. If you have to send that into trucks, truck it to a processing plant, have it decontaminated, and then brought back to, is a very expensive process. And this is also, on many of these sites I've worked on, there is a large requirement for drainage systems, because typically if you're working on a biomass with food waste as the source of fuel, you require large volumes of water. So rainwater is normally harvested from the building, and this requires either large storage tanks or even a pond arrangement on the site. So you can recover that water and use that in the process. So there's some of the issues to do with ground. Another issue I've come across on several projects is odor control of the building. Obviously, biomass plants with food waste It's generating huge amounts of odor from the material itself. And also in the processing of recycled material or sourcing recycled material, again, you're going to generate a lot of odors and bad smells. And therefore, the design of the ventilation system has to be carefully controlled. On one particular project, the ventilation system was designed in conjunction with the gasification unit. So shall we say, the bad air from the food processing plant was taken and put into the gasifier and burnt as oxygen within that process. But then the client said, well, what happens if that's not operating? What are you going to do, etc. So we ended up with long discussions about how we resolve the issue. Obviously, this can be hugely impacted by the location of the site. Unfortunately, some of these recycling centers are located close to residential property. Therefore, you have a further consideration in terms of contaminating the environment with bad smells and odors. One particular project, the contractor ended up installing a very expensive and quite complex filtration system to take the smells out of the air. And that was using very large tanks with a lava rock. And then there was a special culture of bacteria, which was used to break down the bad smells in the air system. And another project where it's on the client tried to force us down the road of using an ionization system, whereby the air that you're treated is charged with electrical charge, so that the molecules of the air can attract the odor that's in the air, and then that can be filtered out, etc. These are all very expensive solutions. Careful consideration has to be given to the access points into the buildings, both for domestic waste control and food waste control. Typically, you will have automatic door systems. So again, if you're trying to control the volume of air and the odors that are within the building, if doors are continually opening and closing to allow vehicles into the plants or into the facility, then you have to take great consideration of the automation of doors. And even on one project I worked, we ended up putting an air mist system across the doors. So even when the doors were open, there was still a barrier which could hopefully protect against the odors being escaped from the building. So there's typical examples. And finally, in commissioning, if you have a combined system where you're processing domestic waste, and then you're using that as a refuse-derived fuel, you have to have sufficient volume of that material to ensure, if you're, for example, commissioning a gasification plant, that you have sufficient volume, and that volume can be processed. It's particularly key, I found, on some of the projects about food waste. You need large volumes or tonnage of food waste to start your biomass process. And if you're starting a biomass plant with food waste, it can take a long time for that bacteria to start to build up and generate its own heat, and therefore produce the methane gas, which you're going to use for your generating process. So on a couple of projects, we ended up having to purchase biomass feeder, which has already a culture of the microbes, etc., to start the process, and that accelerates. Otherwise, it can mean the commissioning period for a biomass plant could, instead of being 3 months, could be 6 months or more if you have to wait for that culture to develop within your biomass. And finally, once you've got your plants up and running, you're going to be producing power, hopefully. From my experience, a large percentage of that power will be used to operate the plant itself. But then hopefully part of the model of the design is that the other power that's not being used can be exported to the national grid and sold on as electricity. And there has to be very careful commissioning process to ensure that the power that's being generated from the plant can be connected to the grid, and often you have issues to do with synchronization of the power generation of your plants with the national grid, et cetera, et cetera. And that concludes my section, and I'll pass over to pull up your.
Thank you both. I think we're going to change over onto another slide pack. So while Trevor does that, thank you both. I'm here to just pick up on some of the points that Zaffer and Trevor have spoken about, but from a contract and disputes perspective. I'm hoping that slides I spent Sunday evening preparing. It's promising. Lovely. Is it worth me having? Well done, thank you. Is it worth me having your machine, and I'll drive myself. Thank you very much. So the sort of issues that Trevor and Zaffer have talked about, of course, from a contract and disputes perspective, play out in the issue for contracts lawyers and disputes lawyers as a question of contractual risk. And whenever I think about contractual risk, I end up thinking about this particular quote from Donald Rumsfeld in 2002, the famous one that he apparently off the cuff made while talking about weapons of mass destruction in Iraq, which isn't an obvious link to waste to energy, I'll accept. But does it seem to me, while widely derided in 2002, quite neatly encapsulates some of the issues that contracts lawyers and disputes lawyers have to think about in terms of contractual risk. And what I'm going to try and do is focus on one part of what the Don said about risk, and that is the known unknowns, which I think are particularly appropriate and apt to waste to energy contracts, design, procurement, and construction. Based on my experience of looking at domestic and international disputes in waste to energy, particularly in incineration plants, thermal plants, as opposed to digestion plants, many of the disputes that arise from a particular approach to design and procurement that's been adopted over the years, which is what I might call in slightly rude parlance, a mix and match. Developers and contractors look at the construction of what is actually a rather complex process by reference to picking particular components, often proprietary, and linking them together to form a particular overall process, rather than thinking about the process as a unified engineering process overall. So you'll find that they'll say, okay, I want a fuel crane, so I'll go to DMAG or Kone, and I'll have a great fuel crane from those. And I don't want a boiler, so I'll go to the local boiler supplier, or I'll go to Hitachi for a grate or an ash conveyor, and they plug them together, and hey presto, you expect at the end to have a fully working waste to energy incineration plant, and it often doesn't work that way. What happens is, on my experience, you multiply the interfaces in design and construction, multiply the problems that you'll incur if you don't think through in advance how you're going to deal with those interfaces, both contractually and as a matter of practice in design and construction. So my experience is that, I'll try to break this down a bit, there are probably four main areas that cause disputes with respect to waste to energy plants. Failure to think through properly at the procurement and contracting stage, how you're going to structure the procurement and contracting. That's the mix and match problem. Inadequate provision for the design, coordination and construction interfaces, depending on which contract procurement process you've adopted, which I'll look at in just now. A particular problem, which I'll end up with, is, I think, how one defines success in a waste to energy environment. How do you describe what you're looking for at the end? Most people think of waste to energy, right? What I want to do is I want an output, I want power output at a certain level. That's my agreement with the grid. But actually how you get there by a mix and match approach is really quite difficult if you haven't thought through how you're going to achieve that. The last one I put in, I'm not going to deal with, which is regulation, NIMBYism, which is, I think, primarily what Trevor was talking about in terms of odor control and that sort of thing. Luckily for me, I've not spent a great deal of time looking at NIMBYism problems. But I think these are all generally what the Don would call known unknowns. These are things we all know about, we know they're problems, but we have to, I think, where disputes arise, when people haven't thought through how to deal with those problems properly in advance. again, my experience is the traditional choice in procurement structure is not being followed in quite the same way as when I was young. Remember, it no longer is this hard and fast distinction between choosing an EPC style procurement, planting all the risk in design and build to the contractor, versus taking on a professional team who design a nice process for you and then hand it over to the contractor who then builds it for you. That's not really being followed, and particularly not in WTE scenarios, I think. It reflects this mix and match approach, this buying or specifying proprietary components and building the plant that way. Contractual hybrids, I think, are common, and these do, unless they're thought through properly, increase the interface risk, both in contracting, procurement, and design. So EPC, a lot of people would say, certainly if my vintage would say, well, EPC, that's the answer. So you hand the whole thing over to the contractor, say, this is what I want, to define your outturn, performance requirements, and wait for the end of the day, pay the bills. What you'll get is, what you bought. And that, I don't think, is a panacea for WTE plants in particular. I don't think it is appropriate to try and pass all risk in procurement design onto the contractor. Clearly, one of the big problems and big complaints about EPC contracting is always the employer's concern about designing down and not getting what you're paying for, and sometimes that's justifiable. But I think the problem with waste to energy procurements and projects that I've seen is that, again, this issue about contractual interface, what you see in the EPC scenario, in a WTE scenario, is difficult unless you've thought it through in advance, is how you deal with specifying what you want from the contractor and matching that with what you're obliged to provide to the third parties, at the very least. That is the grid, for example. How are you going to achieve the outputs that you're required to achieve at the grid? And often, as part of this sort of hybrid approach to procurement and contracting, I've seen is employers taking on certain aspects of the project themselves. The particular issue with civil works, groundworks, as Trevor was talking about, when you've got a difficult site, often there'll be decontamination works or specialist ground contractors brought in to look at, either investigate or deal with the ground. And those do cause problems. And I know Trevor's spoken about ground conditions. I won't spend much time going back over it. Just a little sideline though. While the Don was particularly derided for his comment in 2002 about the known unknowns and the unknown unknowns, many people thought it was an off-the-cuff comment. A little wiki search suggested it wasn't at all off the cuff. It was a comment that came from NASA reports, which Don had seen in a few weeks beforehand. Now, NASA reports are clearly nothing to do with WTE. They're well beyond my expertise, probably the subject for another talk at some point in another life. But actually, the NASA reports came from, or took these particular ideas of the known unknowns, risk, from this report, which is all about construction, ultimately. Known unknowns in ground conditions were identified in part of the British Columbia Royal Commission inquiry into uranium mining in 1979. The history, as I'll explain, goes much further. But number one there is a description about how you deal with ground conditions, or how you recognise, or people recognise, that ground conditions in particular are the classic exemplar of the problems that contracts lawyers and disputes lawyers recognise in dealing with risk allocation in contract, because inherently ground conditions are unknowable, except of course, they're going to be a problem, particularly when, as Trevor says, most of the WTE plants that I've come across, like Trevor has, are built on or adjacent to historic waste sites or landfill sites. If you'll pardon the pun, there's going to be rubbish in the ground. What that means for developers and contractors is they must think about that inherently unknowable nature of the ground when either tendering or defining what you're looking for from the contractor. Do you, as the employer, choose to go down the route of extensive and probably prohibitively expensive investigations in the ground beforehand, so as to provide shiny reports which try and define every single problem with the ground, and then find there's still a fridge freezer at 20 meters down, which you hit with your pile? Or do you say, right, everything goes over to the contractor, sort of FIDIC Silverbook style, which of course we know doesn't always work. It's always going to be that risk, which is going to have time and cost impacts for all parties, and come at it from the perspective of the likes of me, the potential for dispute. The other aspect of procurement, going back to my previous slide, is what one might call the more traditional professional team, contract. And I would suggest that, again, based on experience, those projects that have adopted this slightly more traditional approach bring in Ramboll, for example, or somebody who consults and designs upon WTE plants, as fantastic as they are. The mix and match process or approach to procurement and design doesn't always lend itself particularly well to that style of contractual procurement. It's something that developers need to think about, because not only is there this alternative concern that developers have about potential for over-design, conservative design, which again can be justifiable in certain circumstances, it seems to me there's a problem with this mix and match component-led building of a process does require developers, design teams, contractors, lawyers to think about how the interfaces between that sort of approach to procurement work together with the chosen design team and the level at which you are going to farm out, if you like, aspects of design to component designers, suppliers, and manufacturers. That's what you're going to do. Take the fuel crane example. So you take your consultant at Ramboll. You say, right, what you want to do is you want to find one of X number of cranes. On the market, there are VMAG, Kona, whoever, Stana. This is the specification we've got. What you need to do is you need to tender out to each of these suppliers what you want from the fuel crane. And you get the tenders back and you choose with advice. But of course, when you do that with 17, 18, 19, 20 subsystems, what you're actually doing is you're taking 20 different design interfaces, potentially construction interfaces as well. And it's actually, unless you think it through carefully, quite unclear where the responsibility and risk lies in that aspect of design. So from the advisor's perspective, you'll think about how you're going to apply that risk. Who is going to take overall responsibility for that? And one of the ways it's dealt with, I've seen, and I don't think it's really the answer, but it's actually probably the best we've got, is to try and define by performance specification what you want at the end. Now, waste to energy, I think, produces particular problems in this respect. And you see it quite often in process that you'll define performance specification. I want a particular output or a particular quality of chemical or whatever you want. Waste to energy, I think, produces particular problems in that respect, because even if you conceive the process correctly and you think about your design interfaces correctly, the time comes that actually what you're trying to do when you define the performance specification is usually to define the output, that's the power output of the plant, because what you're trying to do is you're selling on under a power purchase agreement, power onto the grid, and that will have parameters with which you must operate. I think this produces some of the greatest challenges for the definition and drafting of these forms of contracts, whether you adopt the EPC approach or the more traditional design approach. For two reasons. One, unlike looking at the incineration approach to waste, and I think it's true also of digestion, but probably to a lesser degree, there's an inherent uncertainty in the fuel mix that presents itself with incineration of waste to produce energy. I took this particular drop, you can see actually, it's a very colourful series of arrows going across the page. I nicked this from the New York Metropolitan City report into waste management for 2013. And I chose it because it's not just colourful, but because it illustrates one particular point, which is the number of different types of waste that go into assessment of what you're going to do with waste is quite important. What you'll see, not very easy to accept, is in the very top, the very small bit, is diverted waste. That is what Trevor was talking about, of these diverted waste, cardboard, glass, being taken away and moved and then recycled. And you can see, so in New York, and I think it's probably as true about many other countries, and the vast majority of refuse waste goes into the big grey section at the bottom, which is what you're going to do with the remainder, how you're going to use it, incinerate it. If you're incinerating it, what you've got is a series of different fuel types, all with different heat outputs, shoved into a furnace altogether, which produce vastly different heat outputs, unpredictable heat outputs. Now, my most recent waste-to-energy plant that I've looked at in January this year in Thailand, the contract draftsman chose, probably not entirely wisely, to describe the heat outputs or the expected thermal outputs by reference to this diagram, which was put into the contract. Now, at the minute, there's a certain tribunal in Singapore who are scratching their heads about what that all means and whether or not anybody's in breach as a result of failure to get somewhere within the parallelogram the heat outputs. What it illustrates, though, I think, is the difficulty for draftsmen, for developers, contractors, to try and define what is success. If you can't tell in advance what will be the quality of the fuel you're going to use, because it will be constantly changing, whether you mix it with landfill or you mix it with fresh municipal waste, or you mix it with food, plastics, which have high outputs, or wood with lower outputs, for example. How are you going to ensure that you achieve the purposes of be it completion testing, performance specification testing, performance guarantees at completion point, or for that matter, for the future, the next 25 or 30 years of operation, that your plant is going to operate within the performance criteria that the employer, the owner, is obliged to meet for grid outputs under its PPA. And that's something that's really quite difficult. I haven't got an answer, I'm afraid. But it's something you need to think about, it seems to me. Now, I said there'd be more about the Don's quote. Not only was it something that came from the Iranian, actually, not many people know, I've managed to find this, that the original ideas behind Donald Rumsfeld's quote came from this man, Ibn Yamin, who is a 14th century Persian philosopher poet, apparently. And he described this idea of risk of knowledge in these words. And I think just now we're reaching our time, all I can do, I think, is to hope that all of you, whether you are designers, developers, lawyers, advisors, find your horse of wisdom and achieve success. I know lots of you will be on limping mules. If you are, you know where to come. Thank you. That's me.
Just a closing statement, Andrew? Yeah.
Thank you to our panel. Is there anything that's the operation contractor basically Washington's issues tips or stories?
I think from my experience, I mean, the plant is going to deteriorate once it's initially commissioned. You are going to achieve certain performance, and as James talked about, I mean, unfortunately, that performance is going to drop off for various reasons as the plant performs, hopefully until its 25, 30-year cycle of operation. I have worked with clients where they have had insurance-backed type guarantees. So not only do you have a sort of guarantee of performance during the construction of the work and during the commission and during the defects liability period, but they've had extended that maybe for 5 years beyond the initial operation of the plant on an insurance-backed scheme. That can be quite expensive, but that is one option a client can take. But I think the design and having to operate, like I say, initially when it's commissioned, it's going to operate its maximum, hopefully at its maximum performance, and that's going to deteriorate over time. But I think that needs to be factored into the design and to the agreement with either the designers or the contractors themselves. I mean, that's from my personal experience. I don't know.
From my experience is, I think the plant should be run in accordance with the design specifications. So if you design a plant with a variable feed, make sure that feed requirements match what you do. Maintenance is another critical aspect. I mean, normally the get out clause for the maintenance company is that you haven't complied with our maintenance regime. So it's just maintaining the plant regularly and routinely and operating it correctly.
From a disputes lawyer's perspective, and I appreciate this is possibly not the most commercial observation, but if what you're looking to do from the employer's perspective is to try and achieve some level of comfort that in the future you've got some recourse, some thought might be given to the possibility, for example, like in the FIDIC conditions you see, for tests after completion. And what we often focus upon is the performance tests on completion to show completion, the takeover moment. You've achieved the criteria, and as my little graph showed, actually quite difficult sometimes to define that. But once you've got a usable performance guarantee specification, nobody's in principle subject to pricing and risk, which an employer would have to bear if that's what it wants, is to think about setting tests, post-completion tests. Now, all contracts will have at least a year, possibly 2, of defects rectification period in some form or other. There's no reason why you can't think about having some equivalent rerun of the same tests or something else at the end of your defects liability period, and possibly again in 2 years' time after that. The problem you've got, of course, I think these gentlemen are talking about, is that I think waste is a particularly hostile fuel type environment. So there's going to be very rapid degradation of very large, very significant numbers of any metallic components within the plant. So the cranes, the fuel pits, the grates are subject to a very hostile sort of fuel type. And that is something which, if you're going to try and think about how to obtain some level of comfort about the future, so you have something to point to and say, well, it's not doing what you told me it would do 5 years down the line, the contractor is going to be thinking, well, I'm supposed to be guaranteeing this in 5 years' time. What's it going to look like if you've put 5 years worth of rubbish through this and you're going to pay for it? Sam, yeah, Sam.
With the fuel vehicles varying, how do you typically see contracts legal counsel here? How do they kind of decide on when people have been active testing monthly test or is going in or coming out?
So the most recent one I've seen, which is the one I showed you the graph of, was in the page before that was a description of percentage of waste types described. So it was a percentage of landfill up to 2 years old, percentage of plastic, percentage of municipal fresh food waste, percentage or whatever. So that particular contract was terminated before completion. So whether or not somebody's going to pick through and put in black plastic bags of X or Y, I have no idea. But at least in principle, the purposes of describing a successful performance test, that clearly you're right, there does need to be some thought given to how you're going to try and deal with that inherent uncertainty in fuel overall. The graph itself, although it was very quickly shown to you and is quite complicated, the ideas behind it, as I was sort of taught about the case, were that the upper levels reflected in practice the high outputs of plastics. So what you were allowed to do was, if it turned out that for a period of time in 24 hours, there was very high plastic content, the heat outputs would accelerate and grow. And what you were supposed then to do was to damp the fire and get it back down into yours. But you were given a couple of hours to do so. So you were given a margin of error. But of course, how much of that is done, back to your question, actually, how much is done over time and how much damage during the meantime, but constantly letting the fire run away and then bring it back down again with water, dousing, who knows? But I think in terms of trying to define completion criteria, performance guarantee criteria, you need to be quite careful about expressing what will be the quality of the fuel you're going to put in, because you have this inherent uncertainty.
One project that I worked on with a sort of standing joke on the project was, on the 2nd of January every year, 90% of the waste is going to be champagne bottles and whiskey bottles. And therefore you could never understand the profile of the waste you're going to get. And it does vary through the year. And the other big factor was the moisture content. Obviously, if you're putting this waste into an incinerator or gasification unit, the moisture content is a very high factor in there. And some plants are designed so waste heat is used to dry the material as it's going in through the process. But that can be a costly use of the waste heat you have, because ideally you're taking the maximum amount of heat you're producing from gasification or incineration to produce steam, to produce electricity, because that's your ultimate win on the project is to be paid for pumping electricity into the grid. So, but yeah, moisture content was a huge concern on a couple of big projects I had, more than the waste profile. But the other consideration was, will waste profiles change in the next 10 years? You know, I mean, it's a huge push to stop plastics in the environment. You know, people don't use plastic bags anymore. You can go to shops now where you don't have to have plastic vegetable wraps and et cetera, et cetera. So is the profile of waste going to change in the next 10 years? Probably. So if you're designing a plant for 25 years, in 10 years' time, it may no longer be ideally designed to suit that waste profile.
You're saying that just discount contracts that approach, and so saying the design team impact that so better so what exactly
Yeah. So I think, yeah, no, fair enough. I think the so recent ones I've seen it as what I call a bit of a hybrid. Quite often there is design and build or EPC underlying it, but the employer is either bolting on contractors around it, so civils or groundwork contractors, and that creates an interface between EPC and your directly employed contractor. So in that sense, it's not pure EPC. The idea is you just push the whole risk of the whole thing from beginning to end on the contractor. The other thing as well, which is, again, within the structure, you've got to think about, I think, this idea of the package procurement. Is the extent to which, and this very much depends upon who the client is and the developer. When you build the process, I think that people have been doing by means of choosing proprietary components, the fuel crane or the crate or whatever it has to be. And the employer is dictating to some extent, I want you to use Hitachi, I want to use Kone, I want to use Kune or DMAG or however it sounds to be. You actually, it's not EPC. You're getting something that looks a bit like the old-fashioned nominations. That too brings in, as we all know, if you think back sort of when JCT used to have the nominated subcontract packages, some real issues with who takes responsibility for the choice that's been made of the potential suppliers. Now, clearly, you can try and pass that on by saying, right, here's my performance spec for the fuel crane or for the grate or for the ash systems. But if it turns out that Kone has been chosen and their grab isn't working properly or doesn't lift, or the cycling time on the crane isn't sufficient to get enough waste into the pits, who takes responsibility for that? If the employer said, I want you to design and build the whole thing, but I want you to use Kone. So it's a hybridized thing. So I think the base, certainly the last few I've seen, base position has been EPC, quite a lot of FIDIC silver, particularly internationally, or something like it. But with these bolt-ons and these other issues which are causing problems, and it's some of the problems I think are a result of people not thinking about what they're doing when they say, okay, I'll take the silver, because the silver is by reputation one of those contracts you think, actually I can just pass it all over. When you start adding things on, of course, those interfaces are the ones I think are quite tricky. It's not on there, but it's on.
It hasn't come up.
That's on the chat. So I think it's probably people saying, "Hal, shut up."
Somebody asking about the questions, whether they could come to the microphone. I think it was the only question on the chat. Yeah. Okay.